Welcome back, physics fans, and here's our first concurrent question. All forces acting at a point is what concurrent is. And here we have a 5 kilogram mass hanging from a rope T1. There's a knot in the center, and the forces are pulling up this way, T2, and that one is T3. This one meets with the ceiling at a 70-degree angle. What are the tensions in all the ropes? So the force of gravity on this guy is mg, and that's going to be 5 times 9.8, and that's going to be 49 newtons. So we have one of them, now get the other ones. So this is a concurrent one. That means the sum of the forces in the x direction have to equal 0, and the sum of the forces in the y direction have to equal 0. We'll do the y because we have one of them. That means the forces up equals the forces down. Then the forces up is only if there's a T2 going up this way. It has a component this way that's called T2y, and the horizontal component of T2 will be T2x. And this is going to be T2 times the sine of theta, that being the theta from the horizontal. And this one is going to be T2 times the cosine of theta, the horizontal. And that's from our vectors, breaking into its components. The angle here is 70 degrees, so that means this angle here is also 70. To the horizontal is 70. So the force up is T2 times the sine of 70, and the force down is 49 newtons. So T2 is going to equal 49 divided by the sine of 70 degrees, and that is going to equal 52.14 newtons. So we found T2, and we found T1, because that tension is going to be supported by that rope. Now all we need to do is find out what T3 is. And we're going to do the sum of the forces in the x equals 0. That means the forces left equals the forces right. And then what do? The forces left is T2 times the cosine of 70. And the forces right, the other way around, is T3. Well, the forces left and right, I got them mixed up. So, yeah, okay, I'll move them. Funny how I left the T's behind. There we go. So T3 is then going to become 17.83 newtons. If you plug the T2 into there, 52 times the cosine of 70, you get 17. So we got all of the forces. Let's do it again differently. We'll do it the direct method. Now, this was the component method, breaking it up into its parts, and then using some of the forces into the x and some of the forces in the y. Now we end up drawing a two-dimensional triangle. And use sine law, cosine law, or just trig if it happens to be a right angle triangle. So first of all, we have to accurately draw a free body diagram of the knot, of the forces acting on the knot. We have T2, we have T1, and we have T3. Okay, now I'm going to ruin the free body diagram and put in my angles. That's that. This angle here is 70. Now I'm not really a true free body diagram. Now I draw my triangle because these add up to 0. Therefore, the arrows, the vectors, all make a triangle because it has to end up where it begins because the total is 0. So take that, that, and that. Where's our 3? So T2, we have T1, and we have T3. This is going to be our 70. This is going to be a right angle triangle. So we don't need sine law and cosine law. We just use basic trig. T1 is 49 newtons because it's just mg. And therefore, we use the tan to get T3. So the tan of 70 is equal to 49 over T3. And we have the opposite and the hypotenuse, so we use the sine. The sine of 70 is going to equal 49 over T2. So rearranging these, just solving for T3. T3 is 49 over tan of 70. So 49 divided by the tan of 70. 17.83, just like up here. And T2 is going to be 49 divided by the sine of 70. And that's 52.14, just like that. So different ways to do it. Thank you very much. Remember, slap that like button. Let's see how many likes I can get on this one. And comment below. Say hi.